Hey, how are you doing? I just wanted to go ahead and make a little video to hopefully help ease some worries some people were having. I'm just a normal student. I go in person, but I was hoping, hey, I could probably go and help you guys out. Okay, so I've had this professor. She's a pretty easy professor. She just take home exams. She grades very easy. Right, I'll put it like that. So don't get too worried. Most of it is just do the work. You get the right answers on the test. It's really not hard. The tests are always pretty easy. It's however long you want it to be. Anyways, enough yapping. I'm gonna go ahead and do one of the first questions that she really goes over, and I'm gonna show you how to do it. All right, we're gonna be using Excel, and on the test, she's probably gonna be like, you can use Excel on the test. She'll probably even state that use Excel. Um, Super easy to use. Anyways, I'll go ahead and start this question. A furniture manufacturer produces tables and chairs. This process involves machining, sanding, and assembling the pieces to make the tables and chairs. For a table, it takes 5 hours to machine, 4 hours to sand, and 3 hours to assemble. This is for a table. For a chair, it takes 2 hours to machine, 3 hours to sand, and 4 hours to assemble. There are 270 hours available for machining the pieces. This is both of them. 250 hours for sanding the pieces, and 200 hours for assembling. If the profit for a table is $100 and the profit for a chair is $60, how many chairs and tables should the manufacturer produce in order to maximize overall profit? What is the number of chairs and tables? All right. So basically, what are we trying to solve here? Right? We're trying to find the maximum profit and the number of chairs and tables. Right? So if we find the either one of those, we should be good. Um, so this is a little overview that makes it a lot easier to sort of see everything as a whole. All the numbers are condensed, okay? And so the way it works out is you have 270 hours for machining, right? So if you have one table and you have, let's say, 59 chairs, you're going to have 5 times one table, 59 chairs times 2 hours, right? So, like, obviously that's maybe over, or actually, yeah, I'm not going to do the math, but you understand it, right? So tables times this, times this, times this, and then times this. So I'll stop yapping. So what I'm going to do is I'm going to go over to Excel. All right, I'm going to set up all nice and neat for everybody. And we're going to have T for tables. And we're going to have C for chairs. And this may sound weird, but we're going to have Z for profit, right? Or Z is generally what you're solving for, sort of. All right. So Z is going to see, you're going to see that all over the place in different examples. So heads up. All right. Then we're going to have our constraints. So this is just a linear algebra course, right? That's really all it is, at least from what I've seen. So now we're going to go ahead and we're going to set up our little linear algebra kind of setup. Not exactly. It's not exactly linear algebra. It's easier. But anyways. Okay. So what is the overall profit? The overall profit is the number of chairs times 60 and the number of tables times 100, right? Off the bat, that's the maximal profit. Well, that's the profit, okay? So we can actually put that in here. We can make a formula. So we're going to do equals, this is the number of tables, I'm put the number here, times 100, plus the number of chairs times 60, okay? And so for now, it's going to be 0, but if I were to put like one table, it's 100, and I'll put 1 and 1, it'd be 160, right? Does that make sense? For now, we're going to leave it, right? So when these numbers change, it affects this. All right. Next up, we're going to start our constraints. All right, so we know one of the constraints immediately, right? What is the maximum number of hours available? So for machining, sanding, and assembly, right? I'm going to do it in order. So for machining, it's 270 hours. For sanding, it's 250 hours. And for assembly, it's 200 hours. That's the maximum amount. So how can we represent that in an inequality? Hold up. Excel is a little weird. Sometimes you have to put a little uh, quotation mark like that for it to make sure it's not doing a formula. So heads up, right? So maximum, maximum, maximum. So what is going to be our other side of the inequality? Okay, let's think about it. We've got 5 hours times the number of chairs plus 2 hours times the number of chairs. Does that make sense? So for every chair you're assembling, it's going to be 2 hours of machining, right? There's a hard limit. There's no way to get around that. Okay, so we can just not code them. We can just write the formula for that, right? And so you can see it one more time. It's 5 times the number of tables, and that's going to be this. This is the number of tables right here, plus 2 times the number of chairs. All right, and I'll double check. Boom, boom. All right, does that make sense? All right, it's going to be 0. Don't worry, because if we were to do something like 1 and 1, that makes sense, right? That makes sense. And all the things formulate off of this, okay? So for the next one, we have 4 and 3. Okay, so let's do equal signs. 4 times the number of tables plus 3 times the number of chairs. Oops. But I did not put the time sign. 4 times the number of chairs. All right. And for the last one, it's 3 tables, 4 chairs. Okay. So 3 times, I have to put the equal signs. 3 times the number of tables plus 4 times the number of chairs. Okay. So we're almost done. Okay, so first things first, if you haven't done it already, you need to do this. If you want to use a real easy shortstop, click Files, go to Options, go to Add-ins, press Go on this part right here, and you're going to press the check mark on Solver Add-in, right? What that'll do is you'll see in the Data tab, the top right of the ribbon, you'll have an extra little area, right? It's called Analyze, okay? Press Solver. So all these things, I've already done this problem before. So this is stuff that'll just stay in there. Okay. So what we're going to do is we're going to set the objective. What is our objective? Our objective is to maximize overall profit. Okay. Look at that. It has a built-in feature right there. So we can literally just press this right here, press Control, and then click. I don't know if you've used Excel. Probably should have. Yeah, you figure out how to use Excel. Sorry, guys. Sorry you haven't used it before. And we're going to maximize this, right? That's how that works, right? How are we going to maximize it? Okay, we're just going to vary the number of tables and the number of chairs. That's really what we're solving for. And then this is the number sort of like that we're solving with or for, I guess. Once we figure out these, that gives us this. Maybe a better way of saying it. All right, next up, we've got our constraints. All right. First constraint is we have the number of chairs times 5, sorry, the number of tables times 5, plus the number of chairs times 3, or times 2. All right, that's our first constraint. We have this must be less than or equal to this. All right, so we've got this right here must be less than or equal to this. Now you'll notice it's like that automatically. You can change it, but we don't need to in this particular problem. And it's the same thing for this one. This is less than or equal to this. This is less than or equal to this, right? We just press OK on the last one. Okay, so what we're going to do is we're going to do it here, and we're going to press GRG nonlinear. I mean, you don't even need to change it. It should be like that automatically. You can press solve, right? I'll give you this. You'll sound bad, but look, there's our answer. Okay. Now, obviously, you're going to want whole numbers, right? Partial numbers just don't work, right? But we can't do that unless we do extra stuff, and this class is pretty easy. So once you've got this, you can kind of finick around. You go up 1, down 1, whatever. But for this class, or for this question that she solved in class, this is what she did. It's just like, okay, this is our answer. Okay. I'm gonna go back to this. All right. So all of these, they're due at the very end of the semester, right? Probably want to do them beforehand so you see how she grades. Maybe not do them all at once. You probably want to do them beforehand. As for like questions like this, sometimes she'll not do a class on that particular day for whatever reason, and she'll do like a take-home assignment. I don't know if you have to do that. I don't know if I'd stake my grade on not doing it though, right? So you may be want to do that. Um, I guess there's more Excel stuff here. I haven't really looked at anything here, but I'm just going to guess that a lot of this is just linear algebra. Whoa, what a guess. That was perfect. Yeah, yeah, this is just linear algebra. Basically, the biggest part of this class is setup. It's like know what your z is. So it's either going to be minimizing or maximizing z, set up the formula for it, and then set up your constraints, right? If you do that, you'll do just fine. You'll do just fine. Um, this right here, if you've ever used Desmos, it's exactly what this is. I talk for a little extra just because sometimes I don't know exactly what I'm going to say. So the main parts are already done. But for a general consensus, that's what the class is going to be, is finding your z, or finding what makes up your z, finding your constraints, and then using some sort of math thing to solve it for you. You don't have to do any of it really by hand. Okay. So if you have other questions, there's other examples that I have here that I can show. Don't know if all of them, like, yeah, that one's not completely done. We didn't do that one. Or maybe we did and I didn't pay attention. It's whatever. But I'll do another one, but not too many, right?